So now you've done the first machine learning hands-on project where you just fit a curve through some points. And now we're going to move to computer vision just so you can see what this can do. And as a student was just pointing out, we're not yet worrying about the details of exactly which model we're using and the detailed parameters of it. But we're going to see what they can do. So here is ML 101 in computer vision. So I'm going to use Google Colab, and I'm going to make a new Google Colab file, move to trash, return to Colab, a new notebook. All right. And let me move this over to the side so I can see it at the same time as the instructions. There we go. And by the way, since I did this, they added the AI feature to Google Colab, so it will help you code, but we're not using that. Not for this class, as far as I know, except maybe a little bit later. Anyway, so we're using standard machine learning problems that have been well established and people have been using them for a long time. This is one. Fashion MNIST is a database. Each image is 28 by 28 pixels in grayscale, and they're in 10 categories, like t-shirt and pullover and sandal and ankle boot and so on. So the task of the machine learning model is to figure out which one of those 10 categories it fits in. So what we're going to do is we're going to take the 784 pixels in each image and feed them in as 784 separate numbers that go from 0 to 255. And then it will pass through layers of neurons like this to determine which category it's in. And in a more detailed scheme, it'll look like this. There's 784 pixels, goes to 784 input values. Then those go to a hidden layer of neurons, each one feeding into every one, and sort of 2 parameters at every junction is. And then it comes out in 10 categories, and those will give you the probability that it's a coat, a sneaker, a bag, or whatever other categories there are. So this is going to define and train the neural network. And I have to use the keyboard to paste for some reason. All right. And you see here we have sequential input. All we're going to have is 28 by 28 pixels of input, which are the pixels, and then one hidden layer of 128 neurons, and then the 10 output neurons. So this is a very simple model. And so it's going to run that. And executing shouldn't take too long. None of these take very long. There we go. All right, so first it has to download the data from a public repository. And now it's going to run 5 epochs to improve the accuracy. So it's automatically split it into training and test images here. And so this is the accuracy on the training set. So at 82% right, and the next time 86% right. And this one looks like it's going to be about 87% right, and so on. It's going to do 5 epochs, each one of them taking about 10 seconds. All right. So notice it got down to 89% accuracy on the training set, and when we run on the test set, it's 87% accurate. So that's pretty good, and as expected. The test set is images it's never seen before, so it's a little bit less accurate on that, and that's normal to be expected. So we can look at the results for the first 20 images here. Well, let me just send a note here. All right. All right. All right. And so what we have here, this is the right answer, like this 9. Then this is the output relative percentage of 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see the first one it got right. The right answer is 9, and it had a 95% chance of selecting 9. So that's good. 2 is right. Now, if you want one it got wrong, you look for lower numbers here. Like here, It got this one right, 80%. Here's 47 and 45. It got this one wrong. This one, the right answer is 7, 0, 1, 2, 3, 4, 5, 6, 7, but instead it interpreted as a 5. Now, you figure out which model this image is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That was image number 12. It got wrong. So I want to take a look at one it got right and one it got wrong. The first one it got right, and the number 12 it got wrong. So I'm going to print out those images so we can see what they look like. And you'll get different answers than I do. There's some randomness in it. So when I did it, when making the instructions, it was number 11 that was wrong. But this time I think it was 12 that was wrong. We're going to see. Maybe I just counted it wrong. All right. So the first one is one it got right. And the second one is one it got wrong. And it couldn't tell if it was a 5 or a 7. And if you look at what they are, a 5 is a sandal and a 7 is a sneaker. And I'm not surprised. I don't think I know a sandal from a sneaker very well either. The images are quite similar. So that's the sort of thing. You can see why it got certain things wrong. Now, you can try changing the training. And if you do, it will take more time and the accuracy for the training set will increase to 94%. But the accuracy on the test set will hardly increase at all. So now you're entering overfitting. You're fitting these exact data points, and you're fitting not only the trend, but you're fitting the noise in those data points. So you get more accurate for what you're training on, but you're not really getting any more accurate for the other data you haven't seen before. That's overtraining. All right. And that's it for that one. That's the, by the way, I noticed this label here is wrong. I should change it. Learning with errors, that's not what happened here. But anyway, that's the first image classification task we've done. And I'm just going to talk about a couple others. So let me see.
Before you go forward, could you explain again how you knew those two were wrong?
Oh, yes. If you go here, how I knew one of them was wrong because this chart is the probability of the output counting 0 through 9. And the first number is the right answer. So the first one is right because there's a 95% chance in column 9. And that means it correctly found the most likely categorization is number 9. But this one found that the most probable categorization was here, and that's column 5, 0, 1, 2, 3, 4, 5. And this is column 7. So in this one, the right answer is 7, but it concluded that 5 was the most probable answer. And it was obviously very confused. It was very equal split between 5 and 7. And here's one. This one should be 4. It got that right, although there's 23% chance of something else. That's so you can see which ones it got confused on. The ones where it has like 99, that means it was very confident that that one category was right. This is the kind of thing you see when it gets confused. All right.
Okay, thank you.
Sure. All right. Let me stop this recording. If I can find the button. There it is. All right.